I know. I must say, all these boxes though were very close. Okay, I had like 2 in there. I had 1.7, I think. 1.51. They were all really close. Okay, so very good. This next section is going to be optimization word problems-ish. What we're trying to do is either figure out the highest value or the lowest value. So in our scenario, we wanted the highest volume. In some other scenarios, maybe you want the least distance. Okay, so we're trying to optimize, meaning a highest value or a lowest value depending on the scenario. Now, we're not going to have enough time to do the example at the bottom, but I do want to go through some strategies that you may have used for your box example. Okay, when you look at the video assignment tonight, we're definitely going to talk about these strategies a little bit more. Okay, first of all, foremost, okay, when you read a word problem, I would try to figure out exactly what it is you want to optimize. What do you want to have the highest value or the lowest value of? Okay, so we'll say what is being optimized. Okay. Basically figure out what is the question asking. Okay, what is it that you want to figure out? Did anybody on their scratch paper draw a picture of a box or visualize it somehow? You visualize it? Okay, so another strategy, sketch a picture. Label values / variables. When it comes to word problems, that's always a good strategy. Did anybody try to write an equation?
We tried.
You tried. Or you did like number crunching. Okay. Did it? Okay. So, write. I call this a primary equation, meaning the main equation that you're going to use. So write a primary equation that represents the optimized variable. So if we're trying to maximize volume, we're going to write a volume equation. If we're trying to minimize distance, we're going to write a distance equation. So whatever it is you identify in part 1, that's the type of equation that we need to figure out. Sometimes, though, it can get a little tricky because the equation that represents the optimized variable might have more than one variable within it. You know how volume is length times width times height? Okay, you have multiple variables. So sometimes we'll have to write a secondary, okay, this is my terminology, a secondary equation to make the primary equation have only one variable. I'm going to put a star by this one, not because it's important, but it's because it's not needed for every type of example. Okay, so this one might not be needed for every question. Did anybody use calculus to help them with their volume calculation? No, so we did, you did?
I mean, sort of.
Sort of? What type of calculus did you do? Did you do derivatives?
I think 5, 4, yeah, that's right. We could have done
You got it? Okay. Nate, what type of calculus did you use?
Well, Jack kind of used statistics. He tried to use lines of
Regression? Okay, gotcha. Once we have an equation, okay, can we think about this? Once we have an equation and we're trying to find an optimized value, meaning max or min, how can you use calculus to find a max or a min? A high point or a low point? Yeah? So, you said it. Okay.
Of the thing that you made.
Take derivative.
That you made.
Yep. Take derivative equals 0. Find critical point. How do we prove if it's a max or a min? Yeah? Sign chart. So basically, the analysis we've been doing all year, we're now going to apply to a physical situation, like making a box. All right, use those for the video assignment tonight.